Welcome to AHA TV. I'm Melissa Matani and I am joined by three fabulous guests this morning. Janice Chyou, Sean Wu and Gisette Reyes-Soffer. Thank you for joining me for a recap of this morning. Now, I know you all went to different sessions this morning, which is really interesting. So Janice, starting with you, tell me about your morning.
Oh, sure. Yeah, this was a fantastic morning. I found it very exciting. I divided my time between the Latebreaker, which was on shocking decision in atrial fibrillation. I'm a cardiac electrophysiologist, so that very much pertains to me. The second part of the morning, I was involved in a digital health program looking at the future of digital health, where we examine AI, machine learning, adoption of telehealth. Very, very exciting.
Fantastic. And what about you, Sean?
Yeah, I went to this really amazing lecture. It's the Nobel Lecture, where a Nobel laureate is invited to the AHA meeting. And in this case, this happened to be Dr. Evar Moser, who had received his Nobel Prize in 2014 for his discovery of the neural circuit, the brain cells that determines the location and also the time sequences in our brain. And so it was quite interesting to see the way he was able to use the animal models to discover what part of our brain tells us where we are at any one time in space.
And what was your main takeaway from that session?
Yeah. So for one, the brain is clearly very complicated, probably way more so than the heart. But what was really interesting is that he was able to show how by mapping all the different parts of the brain, how our brain has a very specific location that is being used to determine where we're supposed to be and if we're oriented in right, left, or going forwards or backwards, which is quite an interesting area of science.
It's absolutely fascinating. And what about you, Gisette? You had a jam-packed morning.
I did. I mean, it's hard to beat a Nobel Prize winner, but within the ATBB space and the basic sciences, translational sciences, I woke up and I went to the feature science lecture where they had 5 presentations on first-in-human treatments. So these are treatments that are in development for various diseases. So 2 things that stood out about this session, not to undermine the 5 presentations, but there was the first use of iPSC cells, and these are human cells that are being put on a membrane to treat heart function in heart failure. So this membrane was placed on a heart, and then it increased how the heart pumped.
Wow.
And so it improved cardiac function in these individuals. So that was really exciting. And then they also had a platelet agent that is novel and sort of goes around some of the limitations that we have with current ongoing therapies. And then the second session was really exciting for me because it's one of our ATBB awardees, and that was Anne-Marie Schmidt, who's also the executive editor of the ATBB Journal. And she received the George Lyman Duff Lecture Award and gave us a trajectory of her career over the last 35 years. And so that was really inspiring. And for me as a woman and as a physician scientist, she really displayed how well her science has been done. And she's a translational scientist, but also a clinician. So it really was motivating.
I mean, these are all such different sessions, but all so fascinating. It's almost like you need to spend the rest of the day catching up on the sessions that you missed, right? Janice, what surprised you most about today?
Yeah, so the Latebreaker, this was quite impressive Latebreaker for atrial fibrillation, which we know is it's an entity that's really increasing in prevalence. One of the issue with atrial fibrillation is appropriately identifying who needs a blood thinner, who needs an anticoagulant, so to prevent stroke. And blood thinners are not prescribed easily because there's the balance of bleeding risk. So some of the Latebreakers that really tackled this question, one of it showed the advance in how we think about blood thinning. And this was featured by the Azilia TIMI 71 trial, where they look at a novel way anticoagulating by using this factor 11 inhibition mechanism. And this basically bypasses some of the concerns that we have with some of the existing blood thinner in terms of what we call hemostasis, and the body's ability to still remain clotted so that you avoid bleeding risk. And that was very interesting and pushed the envelope. But what was even more fascinating was a very timely coupling of 2 trials back to back that both look at this issue, what we call subclinical atrial fibrillation, or in other words, we talk about atrial high rate events. So for those who are not in the field, I think about this daily. For those who are not in the field, when we think about atrial high rate events, these are events that we see on pacemaker or defibrillator that may not prompt the patient to come into the clinic with a symptom of palpitation or atrial fibrillation symptom. And the question that's been in the community for clinicians for a long time is what to do with these, whether or not these are important enough for us to be actionable to start them on a blood thinner, thereby thinking about their bleeding risk and the risk of preventing a stroke. 2 studies back to back today, and I emphasize that very rare for 2 similar studies to be presented back to back, both looking at this, examining the duration of atrial high rate episodes and whether or not those specific populations were in blood thinner, and whether or not the bleeding risk, what the bleeding risk looked like when they're on the blood thinner. The take-home point is that for atrial high rate episodes, your risk of stroke for a given person with a similar clinical profile, it's much lower than a person who comes in with a traditional diagnosis of atrial fibrillation that's picked up on an ECG. And that begs the question for whether or not we actually need different way of risk stratifying patients with these atrial high rate episodes, and different from the traditional mechanism we use to risk stratify patients with atrial fibrillation. So a lot more research to be done, a lot of very exciting things to think about and how we proceed. So I think many more questions, and very, very excited to see this field go forward.
It's really incredible to hear about all this groundbreaking science and in such different, areas. But then talk to me a little bit, Sean, about the real life impact that of what you heard today, how that will translate into your everyday life.
Yeah, so a lot of times when we're here at the AHA meeting, we see the new treatments that are being brought forth. It has a long history going back 10, 20, or even 30 years to the sciences that has been worked on at the very front end. And this Nobel Lecture that I went to clearly is at that very beginning of understanding a process that happens within our brain that leads to changes in our ability to recognize things. So in this particular case, the science was looking at how we recognize our location, space, and also the sequence of how things happen in time. And for a long time, we don't really know how is it that our brain is able to process this kind of information. How do we really know whether we're in location A versus location B, and how do we get back to location A if we arrive location B? And that has been a mystery for decades and more. Now, because of the research that Dr. Moser had done, we now have a very specific set of cells anatomically defined within our brain, where we now can focus on those cells and see what the changes those cells are having, particularly if you have someone who, say, has a certain disease. Let's say Alzheimer's disease, where they can no longer recognize and memorize things. Are there things that are happening to the cells in this particular location called the medial entorhinal cortex? It's a bit of a mouthful, but by finding this location that is the key place to look for changes, we're now having the ability to start tracking and identifying what's the difference between different individuals. What are the variations? One example, we know some people who are extremely good at knowing exactly where to go when you're putting it in a new city, and other people are completely lost and can't get anywhere without a good GPS location finder. What is it that's different between these people? And I think the mystery lies within the cells, which we now finally within the last decade have uncovered as being the source of cells that tell us this kind of information. And I suspect in the future, it'll be probably trying to help people with diseases. So people with Alzheimer, people may have had strokes and are now lost the portion of the brain that is now enabled to process and recognize this kind of information, to see that is it possible that by enhancing the activity of the cells within this area, or maybe even potentially replacing the cells in this area as therapy, we're going to be able to help improve the ability of people to find their way home.
I mean, my husband would love that if I could say, in the future, I'm going to be able to have a cell transplant to give me a better sense of direction.
Yeah, right, exactly.
What were some of your other highlights?
I mean, I think for me, this morning at least, I think seeing Dr. Schmidt's career trajectory was really for me the key.
Well, you were talking about career trajectories, but you've been coming to this conference for almost 20 years. It's 20 years next year, right?
Yes.
Wow, so how has that trajectory been for you?
So I think, my first AHA was in 2004, and I guess I'll piggyback on what you just said, that this is the meeting where you come to see the latest innovations, and I highlighted that by, what we saw this morning, the first in human iPS, use of iPSC cells. And so this is the meeting where you also see crosstalk between communities. And so this is where the basic scientists talk to the clinicians. This is where the cardiologists talk to the pulmonologists. This is where we all communicate. So for me, AHA represents a time to come and meet friends and present my science, but also see how my science is going to grow. And so over the last X number of years, I hope to continue to do that, and that's what I take from this meeting. Where is the science going? How are we going to change what we're currently doing? And so that's what AHA does. It brings us all together so that we can think about the next steps. And I think it's nice that they brought in someone that is totally outside our comfort zone to make us think differently about how we do our own science. So we learn a lot about methods, procedures. I mean, this morning's session also had gene therapy, which I hadn't mentioned, but that's not the first in human. So those are also very nice areas that we're all very eager to understand whether, gene editing in the future is going to help us to cure cardiovascular disease.
I mean, it sounds like you're obviously very accomplished in your own individual fields, but you just come here and you learn so much.
Yeah, I would add to that. I would very much echo what Gisette and Sean said. I think one of the pure joy of being part of the American Heart Association is the ability to interface with people from so many different dimensions. I think today, I'm here with Sean and with Gisette, and we actually have all worked together in different committees in the past. And this is truly unique. I think there's no other organization like this in the world where scientists and clinicians can really sit side by side. We challenge one another in the ways that we think. We challenge one another in the way that we approach things. And I think there's no place better than that, than being at sessions here, where literally as we go from session to session, we are challenged to frame our thought in a different way. And I think we'll all go back to our home institution with new thought, new inspiration to go forward.
Yeah. I think in addition also, the AHA meeting is a place where you get to see people from all different levels of their careers, all the way from undergraduates from college, to very established scientists, who are now towards the end of their career. And I think the opportunity to allow people to share their history, as you mentioned about how the winners of prizes describe their career, from the beginning, is something that's very motivating for someone who is just starting out in their career here and getting to meet and talk to these, very established scientists to learn from them. What is it about their, trajectory that made them successful, and how are the things that they need to be paying attention to, and have the kind of mentorship, which I think is a key part of the AHA community, and this meeting provides a lot of that.
Absolutely. Well, it's been so wonderful to speak to you all, and it sounds like it's been a fantastic, fantastic morning. I can't wait to hear about your afternoon later, but thank you for your time. Thank you.
Thank you.
Yeah.